Tonight, we're going to explore the most alien and misunderstood region in our own solar system, not a distant galaxy, not some exotic corner of the universe that requires billion-dollar telescopes to even detect. The region we are talking about begins just past Neptune, the outermost planet, at a distance of about 30 astronomical units from the Sun. It is, in cosmic terms, right next door. And yet it is one of the most poorly understood, most bizarre, most profoundly strange places in the entire neighborhood of our star. The outer solar system, the region beyond Neptune, contains structures we did not know existed until 1992. Objects with orbital properties so strange that they forced a complete rewrite of how we think the solar system formed. A belt of frozen worlds, dwarf planets, ancient planetesimals, and wandering ice bodies that stretches from Neptune's orbit to roughly 50 astronomical units. And beyond that, a scattered disk of objects on wildly elongated orbits that reach hundreds of astronomical units from the Sun. And beyond even that, the most distant and least understood structure in the entire solar system, a vast spherical shell of frozen objects called the Oort cloud that may extend halfway to the nearest star. This region is not empty. It is not silent in the way science fiction imagines the void between stars to be silent. It is populated with tens of thousands of objects, perhaps hundreds of thousands, perhaps millions of objects we have not yet detected, ranging from boulders to worlds larger than anything on the asteroid belt. It is the graveyard of the early solar system, the leftover material from the formation of the planets, the reservoir from which the long-period comets that streak through our inner solar system originate, the source of some of the most ancient and chemically pristine matter available anywhere in the solar system. And we understand it almost not at all. 7 discoveries about the outer solar system that revealed how wrong we were, how strange the reality is, and why the region beyond Neptune deserves to be called one of the last great frontiers in planetary science. Before we get started, if exploring the edges of our own solar system, the places where even our sun's light fades to something barely distinguishable from other stars, is the kind of thing that pulls at you, hit like or subscribe. It helps us reach more minds that want to think about places like this. Now, let's begin. The year is 1930. A 24-year-old astronomer named Clyde Tombaugh is seated at a blink comparator at the Lowell Observatory in Flagstaff, Arizona. He has been given one of the most tedious and painstaking assignments in astronomy, systematically comparing photographic plates of the night sky taken at different times, looking for objects that move against the fixed background of distant stars. Only objects in our solar system move noticeably against the stellar background over the course of days or weeks. Percival Lowell, the observatory's founder, had been obsessed with the idea of a 9th planet, which he called Planet X, that he believed was gravitationally perturbing the orbits of Uranus and Neptune. Lowell had died in 1916 without finding it. The search had been handed off and eventually given to the young Tombaugh. On February 18, 1930, Tombaugh is comparing 2 plates of the constellation Gemini taken in January, and he sees it, a tiny point of light shifting position between the 2 plates, a point of light moving exactly as a Trans-Neptunian object should move. Pluto. The discovery generated enormous excitement. Here was a new world at the edge of the solar system, the first discovery of a major solar system body since Neptune itself in 1846. Newspapers around the world announced the find. Venetia Burney, an 11-year-old schoolgirl in Oxford, suggested the name Pluto after the Roman god of the underworld, and it stuck. Pluto became the 9th planet For 62 years, Pluto sat alone beyond Neptune, a solitary world in an otherwise apparently empty region. Astronomers assumed the outer solar system was a place of isolation and silence. The planets had formed, gathered up most of the available material, and left behind only Pluto, an oddity, too small to be a proper planet and too far away to be easily studied. Then, in 1992, everything changed. Shocking discovery. Number 1. Pluto is not alone. The Kuiper Belt is real. On August 30th, 1992, astronomers David Jewett and Jane Liu, working at the Mauna Kea Observatory in Hawaii, detected a small reddish object orbiting the Sun at a distance of about 42 astronomical units. They named it 1992 QB1. It was the first confirmed object in what would become known as the Kuiper Belt, a region of the outer solar system stretching from roughly 30 to 50 astronomical units from the Sun, populated with frozen remnants of the solar system's formation. Pluto had not been alone. It had never been alone. It was simply the largest of a vast population of Trans-Neptunian objects that had been too small and too faint for the technology of previous decades to detect. The discovery of 1992 QB1 opened a floodgate. Within a few years, dozens of similar objects had been found. Within a decade, hundreds. The Kuiper Belt had been theoretically predicted as early as 1951 by Dutch-American astronomer Gerard Kuiper, who suggested that a disk of small bodies must exist beyond Neptune as a remnant of the early solar system, and independently by Kenneth Edgeworth. But predicting something and confirming it with actual observations are different things. 1992 QB1 was the confirmation. The Kuiper Belt is not a thin ring of debris. It is a complex, dynamically rich structure. Its population of objects is divided into distinct categories based on their orbital properties. The classical Kuiper Belt objects, sometimes called cold classicals because of their low orbital inclinations and nearly circular orbits, are thought to be the most pristine survivors of the outer solar system's original population. They have remained in roughly the same orbits since the solar system formed 4.5 billion years ago, undisturbed by the gravitational chaos of the early era. Their surfaces, never warmed significantly by the distant sun, preserve the chemistry of the earliest solar system. Then there are the resonant objects, bodies locked into orbital resonances with Neptune. Pluto itself is in a 3-to-2 resonance with Neptune, meaning Pluto completes 2 orbits for every 3 Neptune completes. This resonance protects Pluto from the close encounters with Neptune that would otherwise scatter it to a different orbit or eject it from the solar system entirely. Hundreds of other objects share this same resonance, earning the collective name Plutinos. And then there are the scattered disk objects, bodies with wildly elongated orbits that bring them close to Neptune at their nearest approach, but carry them far, hundreds of astronomical units, from the Sun at their most distant. The scattered disk objects are thought to be Kuiper Belt bodies that were gravitationally perturbed by Neptune and kicked onto extreme orbits. They are the link between the cold classical belt and the Oort cloud. The Kuiper Belt's discovery rewrote the textbook on the outer solar system in one stroke. The region beyond Neptune was not empty. It was full, not full by inner solar system standards, but populated with tens of thousands of objects larger than 100 kilometers across, and potentially billions of smaller ones. And it immediately raised the question of what else was out there that we had not yet found. Shocking discovery. Number 2, the solar system had a violent youth we did not expect. The existence and structure of the Kuiper Belt proved not just that the outer solar system was populated, but that the solar system's history was far far more violent and chaotic than any model had predicted. In the 1990s and early 2000s, the leading model of solar system formation was relatively orderly. The planets formed from the solar nebula, a disk of gas and dust surrounding the young sun, accreting material in more or less the orbits they now occupy. Neptune formed where Neptune is. Uranus formed where Uranus is. The outer regions of the disk were thin and cold, leaving relatively little material to work with. But the process was steady, and the planets ended up where the models said they should. But the Kuiper Belt structure did not fit this model. The resonant populations, the number of objects locked into specific orbital resonances with Neptune, implied that Neptune had not always been at its current distance from the Sun. It had migrated outward, and the process of migration had swept up objects into resonance like a broom. If Neptune migrated, the other outer planets migrated too. Jupiter drifted slightly inward. Saturn, Uranus, and Neptune drifted outward. The migration was driven by the interaction between the planets and the disk of small bodies surrounding them. As a planet scatters a small body outward, the planet loses momentum and moves inward slightly. As a planet scatters a small body inward, the planet gains momentum and moves outward slightly. Over millions of years, this exchange of momentum with the disk of small bodies drives planetary migration. But migration was just the beginning of the violence. A team of European astronomers developed what became known as the Nice model, named for the city in France where it was developed, which proposed that about 4 billion years ago, the outer solar system underwent a sudden and catastrophic rearrangement. Jupiter and Saturn reached a gravitational resonance with each other that destabilized the entire outer solar system. Uranus and Neptune were flung outward into a disk of planetesimals. The giant planets scattered enormous numbers of small bodies in every direction. The inner solar system was bombarded. The Moon accumulated most of its impact craters during this event, called the Late Heavy Bombardment. The Kuiper Belt was sculpted into its current structure by the violence of the rearrangement. Later refinements of this model, called the Grand Tack hypothesis and the jumping Jupiter model, added more complexity. Jupiter may have initially migrated inward toward the position where Mars now sits, before being pulled back outward by Saturn. This migration may have depleted the asteroid belt and stunted the growth of Mars. The outer solar system, the cold and apparently serene region beyond Neptune, turned out to be the record of the solar system's most violent epoch. The structure of the Kuiper Belt is an archive of catastrophe. The orbits of the objects there encode the history of the giant planet's migration and the cataclysms of the early solar system. What seemed like a silent, frozen archive was actually a crime scene, and learning to read the evidence written in the orbits of frozen objects changed everything we thought we knew about how our solar system came to be. Shocking discovery. Number 3. Pluto is a world of unexpected complexity. In 2006, the International Astronomical Union voted to reclassify Pluto as a dwarf planet. The decision was controversial and generated headlines worldwide. The emotional response to Pluto's demotion revealed how powerfully humans connect to the idea of worlds at the edge of the solar system, to the idea of distant frozen places we have never visited. The demotion was scientifically appropriate. With the discovery of Eris in 2005, an object in the scattered disk initially thought to be larger than Pluto, it became clear that Pluto was simply the largest of a whole class of Trans-Neptunian objects, rather than a unique planet. The outer solar system was full of Pluto-sized objects. Calling Pluto a planet while not calling any of the others planets would have required either adding hundreds of new planets to the solar system or applying a criterion that Pluto alone met. But the reclassification debate obscured something extraordinary. Pluto, properly understood, is not a diminished world. It is a world of remarkable complexity that shattered every expectation scientists had. On July 14, 2015, 2015, the New Horizons spacecraft, launched in 2006, flew past Pluto at a distance of about 12,500 kilometers. It was the first spacecraft to visit Pluto directly, and what it found was nothing like what models had predicted. Scientists expected Pluto to be a geologically dead, heavily cratered world, frozen and unchanging for billions of years, scarred by impacts but otherwise featureless. The surface was supposed to look like the moon, cold, gray, ancient, static. Instead, New Horizons revealed a world of extraordinary geological and atmospheric activity. Pluto has mountains, not small hills, mountains of water ice rising 3,500 meters above the surface, comparable to the Rocky Mountains. The mountains are young, geologically speaking. The lack of impact craters on them indicates they are fewer than 100 million years old, a tiny fraction of the solar system's age. Something is resurfacing Pluto. Something is driving geological activity on a world with no tidal heating from a large nearby moon and a vanishingly small internal heat source. Pluto has a heart. Literally. The most striking feature visible in the New Horizons images is a vast, bright region shaped roughly like a heart, about 2,000 kilometers across. This region, named Tombor Regio after Pluto's discoverer, is covered in nitrogen, methane, and carbon monoxide ices. Its western lobe, Sputnik Planitia, is a smooth plain of slowly convecting nitrogen ice, a glacier in slow motion, with no impact craters. It is actively resurfacing itself through a process of thermal convection. Warmer nitrogen ice rising from below and cooler ice sinking, erasing craters as it flows. Pluto has an atmosphere, thin, mostly nitrogen with traces of methane and carbon monoxide. The atmosphere extends about 1,600 kilometers above the surface. It creates a blue haze visible in images taken by New Horizons after closest approach, when the spacecraft looked back at Pluto silhouetted against the Sun. Pluto has moons, not just Charon, which was discovered in 1978 and is so large relative to Pluto that the two are sometimes called a double dwarf planet system. Pluto has 4 smaller moons, Styx, Nix, Kerberos, and Hydra, all discovered after 2005. The system is the product of a giant impact early in the solar system's history, similar to the impact that formed Earth's moon. Pluto is a world, a complex, geologically active, atmospherically interesting world at the edge of the solar system. Its complexity raises an obvious and uncomfortable question. If Pluto is this rich, what are the other large Kuiper Belt objects like Eris, Makemake, Haumea, Quaoar, Sedna? We have visited none of them. We have seen none of them up close. They remain points of light in telescopic images. The outer solar system contains worlds we have never seen, worlds that may be as surprising as Pluto, worlds whose complexity we cannot begin to anticipate. Shocking discovery. Number 4. There is an object that should not exist. In 2003, an astronomer named Mike Brown and his colleagues discovered an object that broke every model of the outer solar system. They named it Sedna, after the Inuit goddess of the sea. Sedna is a reddish world about 1,000 kilometers across. That is not what makes it extraordinary. What makes it extraordinary is where it is and how it moves. Sedna orbits the Sun on an elongated ellipse. At its closest approach to the Sun, its perihelion, Sedna comes to about 76 astronomical units. That is already further from the Sun than any known Kuiper Belt object at its closest point, but Sedna's orbit stretches out to a maximum distance. Its aphelion of about 940 astronomical units from the Sun. Sedna takes approximately 11,400 years to complete a single orbit. No mechanism in the standard model of the outer solar system can produce Sedna's orbit. The classical Kuiper Belt objects orbit between 30 and 50 astronomical units. The scattered disk objects have perihelia near Neptune at around 30 astronomical units, and aphelia reaching a few hundred astronomical units. Neptune's gravity sculpts both populations, but Sedna's perihelion, at 76 astronomical units, is is far beyond Neptune's gravitational reach. Neptune cannot be responsible for putting Sedna where it is. The Oort cloud, the distant reservoir of long-period comets, has its inner edge estimated at around 2,000 to 5,000 astronomical units, and extends far beyond that. Sedna's aphelion of 940 astronomical units is too close to belong to the Oort cloud's main population. It is in a strange no-man's land between the Kuiper Belt and the Oort cloud, in a region sometimes called the inner Oort cloud or the Hills cloud. Sedna has no business being there. Something put it there, and we do not know what. Several hypotheses have been proposed. The most dramatic is that Sedna's orbit was shaped by a passing star. In the early solar system, when our sun was still embedded in its birth cluster of hundreds or thousands of young stars, stellar flybys would have been much more common than they are today. A star passing through the outer solar system at relatively close range could have gravitationally scattered objects from the classical Kuiper Belt onto extreme orbits like Sedna's. The evidence for this is the orbital structure itself, the clustering of Sedna-like objects in specific regions of orbital space that suggests they were perturbed by a single external influence at some point in the past. Another hypothesis is that Sedna's orbit was shaped not by a passing star, but by an unknown massive planet in the outer solar system, a planet lurking in the dark beyond 100 astronomical units, too distant and too faint to have been detected yet. This hypothetical world would need to be several times the mass of Earth and orbit the Sun at distances of hundreds to perhaps 1,000 astronomical units. More Sedna-like objects have been found since 2003. 2012 VP113, nicknamed Biden, has a perihelion of about 80 astronomical units. Several other extreme scattered disk objects have perihelia significantly beyond Neptune's reach. And crucially, their orbits seem to cluster. They are not distributed randomly. They appear to be concentrated in specific regions of orbital space, as if something massive is herding them. This clustering is the primary observational evidence for what is called Planet 9, a proposed ninth planet of the solar system at extreme distance. The hypothesis was formulated in detail by Mike Brown and Konstantin Batygin in 2016, and it has generated enormous interest and controversy ever since. Sedna is the signal. It is the object that told us something is out there that we do not understand. Whether that something is a planet, the gravitational influence of the birth clusters passing stars, some statistical artifact of our limited observations, or something else entirely, we do not yet know. But Sedna's existence is incontrovertible. It is there. It orbits the Sun, and its orbit requires an explanation that current models do not adequately provide. This is shocking discovery number 4. The outer solar system contains objects that should not exist by any model we have, objects that point to processes or structures we have not yet identified. Shocking discovery. Number 5. Planet 9 may be real, and we cannot find it. The hunt for Planet 9 is one of the most dramatic ongoing searches in modern astronomy. And the fact that we have not found it yet is itself deeply instructive about the nature of the outer solar system and the challenges of exploring it. The hypothesis is compelling on paper. A planet of several Earth masses, perhaps 5 to 10 times Earth's mass, orbiting the Sun at somewhere between 400 and 800 astronomical units, could explain the orbital clustering of the extreme scattered disk objects and Sedna-like bodies. The planet's gravitational influence would shepherd the orbits of these distant objects over billions of years, nudging them into the aligned configuration we observe. The challenge is finding it. At 400 to 800 astronomical units, this hypothetical planet receives so little sunlight that it reflects almost none back toward Earth. Depending on its size and reflectivity, it would be between 10,000 and 100,000 times fainter than Neptune at its faintest. At those magnitudes, it would be invisible to most current telescopes. Finding it requires dedicated wide-field survey telescopes with exceptional sensitivity, long observation programs, and the ability to search enormous areas of the sky. The search is complicated by the fact that Planet 9's predicted orbit covers a large area of sky. It could be almost anywhere along a broad swath of the ecliptic. Ruling it out requires surveying enormous portions of the sky to very faint magnitudes, and even then, a sufficiently cold planet radiating very little thermal infrared might escape detection. Every major sky survey is now being mined for Planet 9 candidates. The Dark Energy Survey, the Vera Rubin Observatory under construction in Chile, the Subaru Telescope's Hyper-Suprime Cam survey, all are contributing. The Vera Rubin Observatory, when fully operational, will image the entire southern sky every few nights to extraordinary faint magnitudes. If Planet 9 exists and is in the southern sky, Vera Rubin should find it. But there is a problem with the hypothesis. As surveys have found more extreme trans-Neptunian objects, the statistical significance of the orbital clustering has become harder to assess. Some analyses suggest the clustering is real and statistically significant. Others argue that observational bias, the tendency of surveys to find objects in certain parts of the sky more easily than others because of survey geometry and observing schedules, can produce apparent clustering even in a randomly distributed population. If the clustering is real, Planet 9 is the most natural explanation. If the clustering is a statistical artifact, Planet 9 is unnecessary. The debate is ongoing. The data is ambiguous. The planet has not been found. But the search continues, and the implications of finding or not finding it are enormous either way. A detection would be one of the most dramatic discoveries in the history of solar system science. A new planet, 10 times the mass of Earth, orbiting in the outer solar system, invisible to all previous surveys, hidden in the dark for the entire history of astronomy. A world that could be a captured rogue planet or an object formed in the outer solar nebula and scattered to extreme distance by Jupiter early in the solar system's history, or a primordial black hole, as some exotic alternatives to the Planet 9 hypothesis propose. The absence of detection after thorough surveys would tell us that the orbital clustering is an observational artifact and that our current models of the outer solar system are more adequate than they appear. That would be a different but equally important conclusion. Either way, the outer solar system is withholding something from us. Either a planet or an explanation for orbits that our models cannot produce. The silence beyond Neptune is not just eerie. It is scientifically confounding. Let's step back from the specific discoveries for a moment and appreciate what it means that we know so little about a region that is technically within our own solar system. The Voyager spacecraft, whose journey beyond the heliopause we explored in a previous video, have traveled further from Earth than any human-made object in history. Voyager 1 is currently about 160 astronomical units from the Sun. That is extraordinary. 50 years of travel at 38,000 miles per hour. The fastest journey any human artifact has ever made. And Voyager 1 has not even reached the inner edge of the Oort cloud. The inner edge of the Oort cloud is estimated to be somewhere between 2,000 and 5,000 astronomical units from the Sun. Voyager 1 would take approximately 300 years to reach it at its current speed. The outer edge of the Oort cloud extends to perhaps 100,000 astronomical units, halfway to the nearest star. Voyager 1 would take about 30,000 years to reach it. Our most distant spacecraft, a vehicle launched in 1977 and still operating after almost half a century, is not even a tenth of the way to the nearest boundary of the Oort cloud. We have not explored our own solar system. We have explored a small bubble around our star and assumed that the rest, the vast dark region beyond Neptune, the region that makes up the overwhelming majority of the solar system's volume, is more or less understood. It is not understood. We have barely begun. The outer solar system by volume is almost all of the solar system. If you drew a sphere around the Sun encompassing the Oort cloud, everything within 50,000 astronomical units, the 8 planets, and everything in the inner solar system would occupy a tiny fraction of a % of that volume. The vast majority of the solar system's volume is the outer reaches, the Kuiper Belt, the scattered disk, the inner Oort cloud. The outer Oort cloud, and of all that space, we have made direct measurements in almost none of it. We know the outer solar system exists because we can detect its members from Earth, the brightest and largest of the Kuiper Belt objects, the long-period comets that fall from the Oort cloud into the inner solar system and light up as they approach the Sun. But our knowledge of the region is inferential, statistical, based on the rare objects we can see and the implications we draw about the many more we cannot. The silence beyond Neptune is the silence of our own ignorance. And it is profound. Shocking discovery. Number 6. The Oort cloud is the solar system's most distant and most important structure, and we have never seen it. The Oort cloud is not a discovery in the same sense as the Kuiper Belt. Nobody has directly observed an Oort cloud object in its natural habitat. The Oort cloud's existence is inferred from the comets that fall from it into the inner solar system. Comets on elongated orbits that trace back to vast distances. Orbits that have been perturbed by the gravitational influence of passing stars or the galactic tide, the gravitational pull of the bulk of the Milky Way galaxy, sending these ancient frozen bodies plunging sunward for the first time in billions of years. Jan Oort, the Dutch astronomer, proposed the cloud's existence in 1950. He noticed that long-period comets, those with orbital periods greater than 200 years, came from all directions in the sky, not just from the plane of the solar system where the Kuiper Belt lies. He also noticed that the aphelia of these comets clustered around distances of tens of thousands of astronomical units. He concluded that the solar system must be surrounded by a vast spherical reservoir of cometary bodies, a cloud centered on the Sun but extending to enormous distances in all directions, from which comets were occasionally perturbed onto trajectories that brought them into the inner solar system. This is still the accepted model, but what we have learned since Oort's original proposal has revealed the Oort cloud to be stranger and more fascinating than even Oort imagined. The Oort cloud is thought to contain trillions of objects, trillions of frozen bodies, ranging from tiny cometary nuclei to objects potentially as large as Pluto or even larger, in a spherical shell surrounding the entire solar system. The total mass of the Oort cloud may be several times the mass of Earth, distributed across an enormous volume of space. These objects are not native to the outer solar system. They did not form where they are now. They formed much closer to the Sun, in the region of the giant planets, and were ejected outward by gravitational encounters with Jupiter and Saturn early in the solar system's history. These encounters flung billions of objects into the outer solar system, and most of those objects were lost entirely, ejected from the solar system into interstellar space. But some were captured into the loosely bound orbits of the Oort cloud, held by the Sun's gravity, even at tens of thousands of astronomical units. The Oort cloud is the solar system's planetary ejection waste product. It is made of the objects that were kicked out of the planet-forming region but not kicked hard enough to escape entirely. And it is fragile. At those vast distances, the Sun's gravitational hold is barely stronger than the combined gravitational influence of the nearby stars and the galactic tide. A relatively close stellar flyby can send waves of perturbations through the outer Oort cloud, dislodging enormous numbers of objects from their stable orbits and sending them on journeys into the inner solar system. The comets we see were, most of them, stirred up by such events, by the slow gravitational influence of the galactic tide bending their orbits over millions of years until they fall sunward. There is a hypothesis, never definitively confirmed or refuted, that the Earth has experienced periodic mass extinctions on a roughly 26 to 30 million year cycle, possibly caused by periodic showers of comets from the Oort cloud, triggered by the solar system's vertical oscillation through the galactic plane. As the solar system bobs above and below the plane of the Milky Way during its orbital journey around the galactic center, it periodically passes through regions of higher stellar and molecular cloud density, which could trigger increased comet showers. The evidence for this periodicity in extinctions is disputed. The mechanism is plausible but unconfirmed, but the idea connects the history of life on Earth to the dynamics of the Oort cloud and to the solar system's position and motion in the galaxy. We are not separate from the Oort cloud. We are products of a solar system whose history was shaped by the same processes that created the Oort cloud. The comets that brought water and organic molecules to the early Earth came from the outer solar system. The impacts that sterilized the early Earth and occasionally killed off dominant life forms came from the outer solar system. The Oort cloud is not irrelevant to life. It may have been essential to it, and we have never seen it. Shocking discovery. Number 7. Something may have come from outside. In October 2017, Robert Werik, using the Pan-STARRS telescope at the Haleakala Observatory in Hawaii, discovered an object that the entire solar system science community had been predicting for years but never actually found. An interstellar object, a body that originated not around our sun but around another star, passing through our solar system as a visitor from interstellar space. They named it 1I/Oumuamua, from the Hawaiian for messenger from afar arriving first. Oumuamua was unlike anything astronomers had seen. Its trajectory confirmed it was moving too fast to be gravitationally bound to the sun. It came from the direction of the constellation Lyra and was moving at about 26 kilometers per second relative to the sun when far from the solar system, well above the escape velocity. It had already passed its closest point to the sun It's perihelion at about 38 million kilometers inside Mercury's orbit before anyone detected it. We saw it on its way out. What Oumuamua looked like was deeply strange. Its brightness varied periodically by a factor of 10, suggesting an object with an extreme elongated or highly flattened shape, perhaps 10 times longer than it was wide, or alternatively, a flat disc-like object rotating end over end. Nothing in our solar system looks like that. The most elongated solar system objects we know of are perhaps 3-to-1 in shape ratio. Then things got stranger. As astronomers tracked Oumuamua's trajectory precisely, they found it was not following the trajectory of a simple object responding only to the sun's gravity. It was accelerating, not decelerating as a comet-like object moving away from the sun should. Accelerating as if something were pushing it. In comets, such non-gravitational acceleration is common and well understood. As a comet's ices heat up near the sun, they sublimate, and the escaping gas acts as a weak rocket engine, pushing the comet. But Oumuamua showed no evidence of cometary outgassing, no visible coma, no tail, no spectroscopic signature of sublimating gas. Several explanations have been proposed. It could be a comet-like body made of hydrogen ice or other volatiles that sublimate invisibly at wavelengths our instruments did not cover in the observations available. It could be a fragment of a tidally disrupted planetesimal from another star system, a sliver of rocky or icy material blasted free by a violent event and given a shape unlike anything in our solar system. It could, in the most exotic proposal from Harvard astronomer Avi Loeb, be an artificial object, a light sail from an alien civilization. The light sail hypothesis was not mainstream and was not accepted by most astronomers, who found the natural explanations adequate given the limited data. But the hypothesis captured public attention and raised the question that every detection of something genuinely anomalous raises. What if? In 2019, a second interstellar object was detected. Comet 2I/Borisov, discovered by amateur astronomer Gennady Borisov. Unlike Oumuamua, Borisov looked like a perfectly normal comet. It had a coma, a tail, and showed spectroscopic signatures consistent with typical cometary compositions. It was, apparently, an interstellar comet that was effectively indistinguishable from solar system comets, except for its hyperbolic trajectory. This was, in one sense, reassuring. Not every interstellar visitor is anomalous, but Oumuamua remains unexplained in the fully satisfying way that science prefers. Both detections confirmed what theorists had calculated. Interstellar objects, bodies from other star systems ejected during the formation of those systems, must be abundant throughout the galaxy. Star formation produces more planetesimals than become planets. Many of those planetesimals are ejected by gravitational interactions with the forming planets. They travel through interstellar space for billions of years. Our solar system should be filled with interstellar visitors at any given moment, in the sense that numerous such objects should be present, but most too faint to detect. The Vera Rubin Observatory, with its extraordinary survey capability, is expected to detect dozens of interstellar objects per year when it becomes fully operational. We may soon have a statistical sample of these visitors, a population of objects from other star systems available for study right here in our own solar neighborhood. This changes the outer solar system in a fundamental way. It is not a closed system. It is not a collection of objects that form together around our sun and have been here ever since. It is a dynamic environment that is constantly receiving visitors from the galaxy beyond. Objects from dead star systems, from young planetary systems, from violent ejection events around distant stars, and it is constantly sending objects outward to become visitors to other systems. The outer solar system is not the edge of our solar system. It is the interface between our solar system and the galaxy. What does all of this mean, taken together? We have been looking at the outer solar system since 1930, when Tombaugh found Pluto. For the first 62 years of that span, we thought Pluto was alone. Then in 1992, we discovered the Kuiper Belt and realized the outer solar system was populated with tens of thousands of objects we had never seen. We discovered that the solar system's history was far more violent than any model had predicted, that the giant planets had migrated and sculpted the outer solar system into its current configuration through a period of chaos that lasted hundreds of millions of years. We sent New Horizons to Pluto and found a world of unexpected complexity, geologically active, atmospherically rich, nothing like the dead frozen rock we expected. We found Sedna, an object whose orbit no model can explain, whose existence points to processes or structures we have not yet identified. We engaged in an ongoing search for Planet 9, a hypothetical world hiding in the dark at hundreds of astronomical units, possibly explaining the orbital structure of the extreme outer solar system, or possibly a statistical phantom that will evaporate when more data arrives. We found that the Oort cloud, the solar system's most distant and most massive structure, may have shaped the history of life on Earth through comet showers triggered by the solar system's galactic orbit. And we discovered that the outer solar system receives visitors from other star systems, interstellar objects that pass through on hyperbolic trajectories and carry with them material from distant stellar nurseries. 7 discoveries. Every one of them a surprise. Every one of them revealing that the reality of the outer solar system was richer, stranger, and more connected to the broader universe than our models had anticipated. This is the pattern. This is what always happens when we look more carefully. The universe is more interesting than our best theories say it should be. The outer solar system has been teaching us this lesson for 30 years. Since 1992, QB1 blinked into existence on David Jewitt and Jane Liu's blink comparator plates and told us that Pluto was not alone. The outer solar system is not just an archive of the early solar system. It is not just a reservoir of comets. It is not just a dynamically interesting collection of frozen worlds at extreme distances. It is a record of our sun's birth, environment, its stellar siblings long since dispersed through the galaxy. It is a graveyard of the inner solar system's rejected material, the planetesimals that never became planets. It is a fragile outer shell that feels the gravitational touch of passing stars and the galactic tide. It is a dynamic interface between our solar system and the broader galaxy. And it may contain, hiding in the dark at distances where no telescope has yet looked carefully enough, a world we did not know existed. The silence beyond Neptune is not the silence of emptiness. It is the silence of a place so large and so dark and so far from any source of warmth or light that our instruments have only begun to penetrate it. It is the silence of questions that have not yet been answered, because the right survey has not yet been built. The right orbit has not yet been calculated. The right photograph has not yet been taken. It is the silence that preceded every major discovery in the history of outer solar system science. The silence before 1992, QB1, the silence before Sedna, the silence before Oumuamua, the silence before whatever comes next. The New Horizons spacecraft is still operating. After its Pluto flyby in 2015, mission controllers redirected it toward a Kuiper Belt object called Arakoth, a small contact binary object about 35 kilometers across, which it flew past on January 1st, 2019. Arakoth turned out to be one of the most pristine objects in the solar system, a perfectly preserved relic of the accretion process by which larger bodies are assembled from smaller ones. Its bilobed shape, two lobes gently pressed together over billions of years of slow orbital decay, provided direct evidence for the gentle, low-velocity accretion process called streaming instability that theorists had proposed but never directly confirmed. After Arakoth, New Horizons continued outward. It is now beyond 45 astronomical units from the Sun, the first spacecraft to study the outer Kuiper Belt environment in situ. Its instruments continue to measure the particle and dust environment of the outer solar system, providing data about a region never before visited by any spacecraft. New Horizons' power source, like the Voyager spacecraft's, is a radioisotope thermoelectric generator, and its power output is declining. By the early 2030s, it will not have enough power to operate its science instruments. By the mid-2030s, it may follow the Voyager spacecraft into silence. After that, the silence beyond Neptune will be, once again, unbroken by any human artifact operating, transmitting, measuring. Voyager 1 and Voyager 2, now in interstellar space, are the only human presence in the outer solar system, and they are dying. New Horizons will die. There is no currently funded mission to send another spacecraft to the outer solar system. There is a proposed mission called the Interstellar Probe, discussed in the context of the previous Voyager video, which would be designed from the start for a long journey into the outer solar system and eventually interstellar space. It would be faster than Voyager, reaching 500 astronomical units within 50 years, well into the inner Oort cloud region. It could provide the first direct measurements of the environment between the Kuiper Belt and the Oort cloud, the very region where Sedna and the other extreme scattered disk objects orbit. But the Interstellar Probe is not funded. It is a concept, a scientific priority, a community recommendation. Whether it is built depends on decisions that have not yet been made, budgets that have not yet been allocated, political will that has not yet been demonstrated. In the meantime, we study the outer solar system from Earth, with telescopes that detect the light of distant frozen worlds at the edge of our perception. We are not there. We have never been there. Everything we know about the Kuiper Belt and the scattered disk and the extreme outer solar system is inferred from photons that left objects billions of miles away, traveled for hours or years to reach us, and landed on detectors built by engineers who have never seen the objects they are designed to study. We are doing extraordinary science under extraordinary constraints. The Kuiper Belt was discovered from Earth. Pluto's complexity was revealed by a single flyby lasting a few hours after a 9-year journey. Sedna was found in survey data. Oumuamua was detected as it was leaving. The evidence for Planet 9 is statistical. The outer solar system is revealing its secrets grudgingly, one photon at a time across distances that make the Voyager journey seem short. And with every new discovery, the silence has been revealed to contain more than we imagined. The terrifying silence beyond Neptune is not terrifying because it is empty. It is terrifying because it is not empty, and we do not know what is in it. Carl Sagan, whose influence on the Voyager mission we explored in a previous video, wrote about the pale blue dot, the image of Earth from 4 billion miles away, that made our planet look insignificant in the vastness of space. He used that image to argue for human humility, for the responsibility we bear toward each other, given that the Earth is the only home we have ever known. But there is a companion to the pale blue dot that is less often discussed. The outer solar system is full of pale dots too. Pluto, photographed by New Horizons from 3 hours before closest approach, is a world with mountains and glaciers and an atmosphere and a heart-shaped plain of slowly convecting nitrogen ice. Arakoth is a gentle relic of the solar system's birth, preserved in the cold dark of the Kuiper Belt for 4.5 billion years. Sedna is a reddish mystery circling the Sun on an orbit that has no explanation. These are not pale blue dots in the sense of hosting life. As far as we know, none of them do. They are cold, dark, frozen, almost airless. But they are not insignificant. They are archives. They contain within their chemical compositions and orbital histories and surface features the record of things that happened before Earth existed, before the Sun finished forming, before the solar system took its current shape. The outer solar system is not a place of silence in the sense of having nothing to say. It has been saying things for 4.5 billion years, in the language of orbital mechanics and surface chemistry and impact records and cometary flights through the inner solar system. We are only now, with the technology of this era, learning to listen. The silence beyond Neptune is the silence of a place waiting to be heard, and we are, at last, beginning to develop the instruments and the patience and the scientific framework to hear it. What we will find when we do, what the Vera Rubin Observatory will show us about the Kuiper Belt population, what future missions to the outer solar system will reveal about the worlds there, whether Planet 9 exists and what its nature is, what the Oort cloud looks like up close, what the interstellar objects passing through our solar system carry with them from distant star systems. All of it is still hidden in the terrifying silence beyond Neptune. All of it is waiting. The history of the outer solar system tells us one thing with absolute clarity. Whatever we expect to find, reality will be stranger and richer and more surprising than our expectations. Every time we have pointed a telescope or sent a spacecraft toward the outer solar system, we have been wrong about what we would find in ways that taught us something more valuable than what we expected to confirm. Pluto was supposed to be a dead rock. It is a living world. The outer solar system was supposed to be empty. It is full. Sedna was not supposed to be there. It is. The silence beyond Neptune is not empty silence. It is full silence. Silence packed with objects and processes and histories and mysteries that we have only begun to uncover. And the most extraordinary thing about it is not what we have found there. It is what we have not found yet.